A star.
A great mass in our universe.
A vast and luminous sphere made out of plasma held together by gravity.
And this is their story.
The first stage of the life cycle of a star is the nebula. During the nebula stage, gas, dust, and other particles unite together. The word nebula derives from the Latin root cloud.
Once the nebula condenses, it becomes what is known as a protostar. A protostar is the stage of a star before the fusion begins. The protostar particles become so close together that hydrogen starts to fuse into helium.
Fusion is the process of atoms coming together where they form a different element. Scientists once believed that the galaxy Andromeda was an immense nebula.
"90% of all stars are main sequence stars. During the main sequence star stage, nuclear equilibrium takes place. Nuclear equilibrium is when the fusion of hydrogen is so hot that it causes pressure that is equal to the amount of gravity.
Main sequence stars, including our Sun, are located in the center of the Hertzsprung-Russell diagram. Typical main sequence stars are around 865,400 miles in diameter.
You know a star is turning into a giant when the hydrogen that was in the core runs out. The result of this is a smaller yet hotter core. Due to the increase of heat in the core, the outer layers of the star expand.
Since the outer layers are moving away from the core in the expansion, their temperature decreases. Helium then fuses into carbon, which is used by the star as energy.
Giant stars are typically around 8 times the solar mass of its previous stage, the main sequence stage. Mira, a red giant star, would be a commonly known example of a giant star.
Since the star uses heavier elements for fuel, the core increases even more in temperature.
The outer layers of the dwarf detach themselves from the star, leaving a very hot and dense core. The core is so dense that just a teaspoon of matter would weigh nearly as much as an elephant on Earth.
When fusion of a white dwarf star stops, the core runs out of fuel. Without fuel to give the star energy, the temperature and luminosity of the dark dwarf diminishes. Dark dwarfs are also referred to as black dwarfs.
The time it takes for a white dwarf to turn into a dark dwarf is longer than the age of the universe. Therefore, there are no known dark dwarfs in existence.